Coming back to another notation in complex number, we have from the beginning been talking about r and theta. If this is z, then modulus of z is r. And how do we write theta? We write it as argument of z. Argument of z or amplitude of z equal to theta. So this is just a notation. So you know it is all about r theta. When you see this, remember theta. When you see this, remember r. Talking about distance from the origin is r. What about the distance between two points? That is two complex numbers. So if we have two complex numbers z1 and z2, let's say z1 and z2, then this is the difference or distance between z1 and z2. And we have seen by our parallelogram analogy, if the arrow is this side, we call this z1 minus z2. If the arrow is on the other direction, we call it z2 minus z1. But this distance d between z1 and z2 can be written simply as modulus of z1 minus z2 or z2 minus z1, which is the same thing because the distance doesn't change. This has to be noted, distance between 2 points. This gives us a very neat formula for the equation of circle. We have been dealing with a circle all the time. So let's see a circle. And as you have seen in coordinate geometry, if the center is known, so let the center be called z0 or zo. And we take any point here z, any point on the circumference, then the distance is always r, the radius. So the equation of a circle is z minus z0, that is the distance between 2 points, equal to r. As simple as that. This is the equation of circle. Please note it. It's very simple and very useful. It will be used in many different places. This is the equation of a circle. The important point to note, the difference between these two are that z is a general point in the circle. Any point on the circumference, the distance from the origin will be r. So z is a general point here. Here z1 and z2 are specific points. As in an equation in coordinate geometry, you have x and y which are general points, and we take one x1, y1, x2, y2, and we find the equation of a straight line. Similarly here, this is a general point. Now we'll see some simple applications of the rotation rule that we just learned. The rotation rule simply says that if z is multiplied by ei theta, then z turns in the anti-clockwise direction by theta. So if z is here, it turns by theta. It has gone here. So if this is z1 equal to z into ei theta, if this is z, this is z1. As simple as that. Now we'll see some simple application of this. We'll take a circle and draw an angle of 30 degree here, pi by 6. So this angle is pi by 6. And let's call this point z. Let z be the vertex of a square drawn on the circle. So we can draw a square. Let's say this is a square. Can we find the other 3 points? It turns out that it is very easy to do. We know the property of a square is that the diagonals bisect at 90 degree. So if this is the point and this is the center of the circle, if this is the point z, then z1, let's call it z1. So z2 will be 90 degree turned in the anti-clockwise direction. So Z1 simply becomes I Z1, Z2. This is Z2. Z2 simply becomes I Z1 because we have turned it by 90 degree. Now what about Z3? It is turned by pi. And remember this diagram is very important. We will be using it all the time. This point is I, this point is minus I, this is plus 1, this is minus 1 in terms of complex number. So turning by pi is simply going in the opposite direction, and as we have seen, this is minus Z1. And we have this other thing, this also is a straight line, so this will be minus Z2. We could also have written as this Z3 as Z1 E I pi, and Z4, that is this point, is equal to pi by 2, pi by 2, pi by 2. So Z1 into E I 3 pi by 2. And the result would be the same, because this is pi plus pi by 2, and cos pi plus pi by 2 is negative, sin pi plus pi by 2 is also negative, cos pi by 2 is 0, sin pi by 2 is 1, so minus I. So this is minus Z2, which is equal to minus I Z1. This is about a square inside a circle. Let's see how we will get an equilateral triangle if we know one of the vertices. So if one of the vertices is known, let's say again we draw pi by 6 and we have Z1. How do we find the other two? Now again let's go back to the property of an equilateral triangle, and if the center or circumcenter is here, then this will divide 2 pi into 3 parts, 1, 2, 3. So 2 pi by 3. So the next point will be at Z1 E I 2 pi by 3, turning by 2 pi by 3. So E I theta turns into theta, turns the Z by an angle of theta. So this is 2 pi by 3. Again 2 pi by 3 will come here somewhere. So this will be the third point, Z3. Z3 will be E I 4 pi by 3. And this will form an equilateral triangle.